Alright, so today's lesson is going to start our new unit on quadratics. So we're going to look at what quadratic equations are. We sort of started them in functions and we looked at the different types of equations and we looked at quadratics. We know what they look like. Now we're going to start breaking down some of the key features of quadratics. So today's notes will title Key Features of Quadratics. You can make sure to put today's date. So the first piece of a quadratic is that we need to understand the standard form of a quadratic equation. So standard form means the general form that you're going to see the quadratic equation in. And this is the format that we write the standard form in. It's y equals ax squared plus bx plus c. The a, b, and c just stand for are letters that stand for any number that we can plug in for them. So we can plug in any numbers into these values, and that's going to give us our sense of a quadratic equation. The only number we can't plug in is we can't say that a equals 0, because then it wouldn't be a quadratic equation. So let's look at an example of a quadratic equation. We're going to graph it, and then we're going to identify some of the key features of that graph. So here's an example that we can take a look at. So let's say I gave you this equation, y equals x squared minus 2x plus 3. What I want to do is I want to graph that equation onto a regular 10 by 10 grid. So at this time, you should take the tape and the grid I gave you, and we can just tape that down into our notebook. Alright. So I want to figure out what this graph is going to look like when I plot some points onto it. So I'm going to make my table x I'm going to leave some space because we're going to do some work there, and then what my y values are. So what's going to happen is I'm going to give you a value for x. We're going to plug it in and see what it gives me out for y, and then plot that point. So here are the values of x that I'm going to use. I'm going to use -2, -1, 0, 1, 2, 3, and 4. So what I'm going to do is I'm going to take these values, I'm going to plug them into the equation for x and see what comes out for y. So for example, I'm going to plug in -2 squared minus 2 times -2 plus 3. So I just took those values of x and replaced them with -2. So on my calculator I can just type in -2 squared minus 2 times -2 plus 3. So when my input is -2, my output is 11. Then we can do the same thing with -1. So typing that into the calculator, -1 squared minus 2 times -1 plus 3 gives me 6. Do the same thing with 0. That's going to give me 3. Same thing with 1. my output's going to be 2. Plug in 2 squared, so I've got plug in 2, so it's 2 squared minus 2 times 2 plus 3. So my output here is going to be 3 again. Plug in 3 squared minus 2 times 3 plus 3. This time my output's going to be 6 again. And then plugging in 4 squared minus 2 times 4 plus 3, that's going to give me 11 again. So now I can plot these points. When my input is -2, my output is 11. So I'm going to go to -2 and then up to 11. So I know it doesn't fit. Well, actually it does fit perfectly on our graph. It's going to be that top space there. So -2, 11. I'm going to put a dot way up here. At -1, my output was 6. At 0, my output was 3. At 1, my output was 2. At 2, my output was 3. At 3, my output was 6. And at 4, my output was 11. And I can draw a line connecting these. And then there's my U-shape or parabola. So this is the standard form of a quadratic. And when you graph a quadratic, you're going to see a graph that looks something like this. So from the graph of the quadratic, there are some key features that we can identify that you're going to need to know for classes past Algebra 2 and then also like for the SAT. So the first thing we want to talk about is the shape of that graph, and we've kind of already identified this. The shape of the graph is a parabola. So the special word we use to describe this is a parabola. So any quadratic equation will have a parabolic shape. The point or points, I'll put that in parentheses, so it could be point or points, where the graph touches the x-axis so the point or points where the graph touches the x-axis is called roots or zeros or x-intercepts. There's 3 words for them. Roots, zeros, or x-intercepts. And actually for this graph there are no x-intercepts because we're not crossing on the x-axis. Some other key features that we should know about. There's something called the turning point. So the turning point of the parabola is called the vertex. So the turning point is when you're looking at the graph and you're on the graph. The turning point is when the graph changes directions. So let me zoom back out so we can see our full graph. You can still write down what you need to write down. So in our example, the turning point or the vertex is right there. And that's at 1, 2. So the vertex is the turning point of the parabola. So it's kind of where that hill or bottom of the valley is, depending on the way you look at it. Some other key features that we'll talk about. So something that's very important to quadratics is that quadratics are symmetrical, which means that if I cut it in half, one side of the parabola will flip over onto the other side. So where it gets cut in half is actually important to know when you're graphing, because that means you only have to really graph one side, and then if you know that side, you can just flip it over to the other side. So we have what's called this line of symmetry, or this axis of symmetry. And the axis of symmetry always goes through the vertex of the quadratic. So it splits it in half on either side. So that's why you probably noticed these numbers repeated as we were graphing them. So another key feature that we're going to write about a parabola is cut in half by the axis of symmetry and in this problem our axis of symmetry, and I can just write it as an equation, is x equals 1. So whatever the x value is of your vertex, that's your axis of symmetry. It's cutting it in half. Some other key features we'll talk about are that we've studied already in this previous unit was domain and range. So remember, domain is your x values. So for a parabola, the domain is always going to be all real numbers, because when you look at your graph, for your x values, it's going on in both directions, to the left and the right. So that means that all possible x values are the domain. The range is going to depend on your vertex and which direction the parabola is facing. So if the parabola is facing up, it's everything that's bigger than 3 or equal to 3 for the y values. So all the y values above 3 are on my range. So domain and range will still come up with different types of graphs. One final piece to talk about as well. There are special names for the vertex. So the vertex is called a minimum when it's the lowest and a maximum when it's the highest. So the vertex is called a minimum when it's the lowest and a maximum when it's the highest point. So when you have the highest point, it's a maximum. When you have the lowest point, it's a minimum. So these are some of the key features that we'll see when we're dealing with quadratics. You're going to need to know what the vertex is, the x-intercepts or the roots or zeros, the axis of symmetry, and if it's a minimum or a maximum. I just want to show you as well on your calculators really quick. You could figure out this graph as well without having to do all of the work. If you just typed in y equals, clear out whatever's in there, and do x squared minus 2x plus 3, and hit graph, it'll give you the graph of the quadratic. And if you want to look at the table values, you hit second and then graph. And then you can see these values on your table that we were able to come up with by hand. So that's what we're going to be working on for the next couple weeks.